Let us now prove the other case of this proof, where the median of all these peaks, the agent peaks and the phantom peaks, is a agent peak. So one of these here. So what we are going to do here is that we will prove this for two players, only two players. The general case essentially is a little non-trivial extension, but the idea of this proof remains the same. So I'll provide the references if you are interested in reading that general proof. So before proceeding, we first make the following claim. Suppose we have these two players. We are now only looking at two players, and suppose there are two preference profiles which agree on their peaks. So maybe the preferences might be, so one preference might have a much sharper fall than the other one, but the point is that their peaks remain the same, or the relative ordering between this the alternatives on this side versus this side, that might be different, because there is no rule which says that what will happen for those alternatives which are on two other sides of the peak. That might change, but their peaks do not change. So for both player 1 as well as for player 2, in these two different preference profiles, their peaks remain the same. And then the claim says that then the outcome should also remain the same. So how can we prove that? So let us assume that player 1's peak in these two profiles is A, and that for player 2 is B. And suppose that FP, the outcome in the first case, is X, and the outcome when we change the first player's preference to the second preference ordering, which is P1 prime, and keep the second player's preference the same, then the outcome is Y, right? So, and quite naturally we are assuming for contradiction that Y should not be equal to X, and let's see what happens. Now, since F is strategy proof, we know that under this preference profile P1, X should be more preferred than Y, because here it is assumed that this P1 is the true preference and P1 prime is the misreported one. So if player 1's true preference was P1, that agent should have preferred X more than Y. And similarly, you can say the same for the other preference. Now Y will be more preferred than X. Now, since the peaks of P1 and P1 prime are the same, then if X and Y remains on the same side of the peak, so imagine a situation where both of them, let's say this is the P1, and both X and Y are on this side, and in one case you have X is more preferred than Y, and also at the same time Y is more preferred than X. This can happen because these preferences are antisymmetric. That is, if both these things happen, X is preferred than Y, Y is preferred than X, then they must be the same. So there cannot be any kind of indifferences here, and because of that fact, then if they are on the same side, then they must be the same. So we already get the result. The only possibility is when X and Y are on the different side, then this is possible. But now we are going to show that it is impossible under this setting to have X and Y on two different sides. And why is that? Because remember, X and Y are outcome of a social choice function, and that social choice function has one additional property than strategy proofness. So it is strategy proof and onto. So we have also seen that under this situation, ontoness and Pareto efficiency are equivalent when the social choice function is strategy proof. We have already seen a result like this. Now we are going to use this Pareto efficiency, and we have also seen for Pareto efficiency what should happen. So let's assume, without loss of generality, now X is on the left hand side of this peak and Y is on the right hand side of the peak. And again, without loss of generality, A is less than P. So the peak of the first player is on the left of the peak of the second player. Now, what should happen for Pareto efficiency is that the outcome should lie between A and B. And this is a very crucial point. You can already observe that X is living on the left of it. So that is already a contradiction, because because X is a social outcome of a social choice function, of the same social choice function, which is Pareto efficient, then this cannot happen. I mean, we have this interval A is here and B is here. So these are the two peaks of these two players. Any outcome social choice of the social choice function must live inside it, but we have this x which is living outside, so it cannot be Pareto efficient. So for all Pareto efficient social choice function, this cannot happen. So therefore what we have assumed was wrong. And you can look at the other cases as well. I mean, if B was less than A and something else was true, I mean, this condition again, there should always be some outcome of this social choice function which is living outside that interval, and we will have a contradiction to Pareto efficiency. Now that is for one transition. So we have done the transition from P to P1 prime P2. Now we can complete this transition from P1 prime P2, where we know that the outcome is the same, and then we go to P1 prime P2 prime, and there also the outcome should be same. Okay, so that with that small result, let us get back to the actual proof. Now we have a profile P1 P2 which is given by P, and we know that the peak of the first player is A, peak of the second player is B, and let us denote Y1 is the phantom peak. Now by assumption, because we are in this case 2, the median of these these three numbers here is going to be an agent peak, so either A or B. And we can, without loss of generality, assume the median is A. For B, again, a very similar argument will follow. So let us assume for contradiction the outcome is C, which is not equal to A. We'll have to show that this median has to be the same. This outcome, social choice outcome, should be exactly equal to that median. But let us assume that is not true. Then by Pareto efficiency, we know that C must be within this interval, within the interval between A and B, right? So that is something that we have seen. So there are two possible cases in which A can be a median. Either B is less than A, less than Y1. In that case, A is a median, or Y1 is less than A, less than B. In that case, also A is a median. So these are the two exhaustive cases. So let us look at the first sub case, that is B is less than A, less than Y1, and by Pareto efficiency we know that C has to be somewhere in between. So in particular, C has to be less than A. Now we are going to construct and show a counter example if this cannot happen. So we construct a P1 prime where the peak remains the same as the previous one, as P1 itself, but Y1 and C, Y1 is more preferred under this preference than C. Why is that possible to do? Because now we know that A is living somewhere here, B is here, C is somewhere here because of the Pareto efficiency, and Y1 is here. Because Y1 and C are on two different sides of this peak, peak is this A, then this is possible. You can always construct a preference profile which has Y1 more preferred than C. Now, by the earlier claim, whenever the peaks remain the same, if an outcome, if C is the outcome in this preference profile, then it better be the outcome in the new preference profile as well. So in P1 prime and P2, under that preference profile, the outcome should also be C, right? So this is let's say point number 1. And now we are going to consider a very special profile of player 1, where this is P11. Remember, this is the peak is on the rightmost position, right? So this is something like this. The rightmost position is the peak, and then it is falling down towards the left. So if that is the preference profile, we already know that that is the extreme right. So therefore, the P2 or for player 2, the peak is B. That is by the choice that we have made, and B is actually less than Y. That is how we have. So this is this case. B is less than Y, and Y is less than or equal to this P111. So of course, this is the rightmost point. So therefore, it must be larger than all these things. So in that case, so if we just look at this particular preference profile, P11 and P2, there are this 3 peaks. So one peak is on the extreme right, the second is the phantom one, and you have another agent peak which is B. And because of these peaks are essentially because of these 3 peaks, the median happens to be this Y1, which is a phantom peak. And if it is a phantom peak, we already know the result of case 1, where the median was the phantom peak. So then by case 1, we already know that the outcome, the social choice outcome, should be exactly equal to the median, which is Y1. And now the contradiction happens. Now we know that by construction Y1 is more preferred than C, and we know that the outcome at that case, that preference profile, is C. Then you already see a kind of a manipulation which is possible by player 1. It prefers Y1 more than C, but the outcome is actually a worse outcome. While if it manipulates its preference from P1 prime to P11, it gets this outcome which is Y1, which is more preferred than the current outcome, which is C. So F cannot be strategy proof. So this is the contradiction that we actually lead to, and therefore what we have assumed was incorrect. So this should also be the outcome. The outcome should be exactly equal to A, which is the agent peak. And a very similar complementary analysis you can do when Y1 is less than A less than B, and the Pareto efficiency will imply that A must be, so C should be between A and B, and you can just replicate the same arguments, the same proof. I just skip that for you to observe and redo. All the steps are done here, but you just have to understand them appropriately. So there also you will have a contradiction to the strategy proofness, and essentially then you can conclude that the outcome in both these cases has to be the median, which is the agent peak in this case. And now to complete this proof, so this completes the proof of case 2 for 2 agents. For the n number of agents, you can take a look at this original paper which proves it. This is a highly readable paper and also interesting to read. So the title of this paper is on strategy proofness and single peakedness. So this gives a ton of results that we have proved in the previous module and in this module.